Hi, in this video we're going to look at the nth root of unity for complex numbers. Okay, so here I'm going to, I got z to the power 1 is 1, which is not particularly very useful. What if I make n, and I can change n with this slider. Let's do cubes. Okay, and if I got z cubed is equal to 1, if we put the complex number 1 on our Gantt diagram, okay, have modulus 1 and the angle will be 0 pi. So in r cos plus I sine theta, it will be this format, cos 0 pi I sine 0 pi. Then if you apply De Moivre's theorem to that, then because you want z cubed, then it becomes z will be 1 to the 1/3, which is 1, and then this bit you also have to raise to the power 1/3, but then you can apply De Moivre's theorem by bringing down the 1/3 in front, okay, and adding 2k pi to each of the angles, and as long as you work these out, then you can find the different values. Okay, so when k is 0, which is this case here, in this particular case, we're going to get 1 to 1/3 cos 0 pi plus I sine 0 pi. If I change the value of k using this slider here, hopefully. Okay, so this is when k is 1, so this is this situation here. Then this becomes 1/3 of 0 plus 2 pi, which is 2/3 pi, and then 1/3 plus 0 plus 2 pi, which is 2/3 of pi, and you get this next complex root here, where this angle is 2/3 pi. And if I make k is 2, remember you always make k, you always make k 1 less than the value of n. You'll get the third one here, okay, where this angle here is 2/3 pi minus 2/3 pi. You'll get this angle here, and then evenly spaced out. Okay, so these are called, in this case, the cube root of unity. Okay, so here we have them all here. Now, normally what you do is you let omega stand for the first z1. Okay, and then you can get the other one will be 1 plus minus 1/2 plus root 2i. The next one would actually be this complex number squared, actually. So if and then you'll get minus half minus root 3 over 2i. If you add these together, so minus 1/2 plus minus 1/2 plus 1 gives you nothing, and then root 3 over 2 minus root 3 over 2 also gives nothing. So the sum of the roots of the nth root to cube root to unity will be equal to 0. In fact, if you notice, this is actually a GP, and you can find the sum if the first term is 1 and the common ratio is omega, then it will be 1 minus omega to the power of n over 1 minus omega. So if and anything to the power of n will be 1. Because if we take omega cubed, which is the value of n in this case, you get back to this one. So you'll see that this is 1 minus 1, which is 0. 0 divided by anything is actually 0. Okay, so the sum of the roots to the nth root of unity are actually equal to 1. Now you can change the value of n. Get the same idea. You can check here. We've got 1 minus 1 and then plus I minus I, which gives me 0. Okay, 5 is not very good. You don't get very nice value for some reason. You don't get very nice value. But if you take 6, and if I was to move this, oh, sorry, I can't do that. If I was to move, okay, I don't seem to be able to move it. But if I was to add these up, maybe make that bigger there. Let's do it this way. So just move it over here. The problem is with n is 6, you get quite a large complex number. But there we go, you can see here, if I sum these up, I get 1 plus a half minus a half, that disappears, minus 1, I got 0, minus a half plus a half will make 0, and the same will happen with the imaginary bits. So I've got 2 lots here and 2 negatives here, that will make 0. So again, I will get that the sum of the roots will be equal to 0, and they also form a GP. Okay, and you can see that the roots to unity are evenly spread around the circle, which have a radius of 1 unit. The angle being, in this case, pi by 3, so evenly spread all the way around the circle. Okay, so I hope you've understood. So this has been a video about the nth root to unity. This GeoGebra app, which will help you sort of try and understand what I'm sort of saying here, will be in the notes of the video. Sorry that the width is so big, but there's the only way I could get this one actually in to illustrate the point. Okay, so thanks very much for watching.